Hello class, today I'll be talking about the design of the Cessna 172. The way I'll go over this presentation is I'll do it in the way a proper pre-flight inspection is done. So I'll start in the cockpit, go around to the tail of the plane, go to the starboard side of the wing, and then go to the nose of the plane, right to the port side of the wing. So as we're walking up to the airplane, we can see that it has two wings. It's a single engine airplane, and it has a tricycle landing gear, meaning two wheels in the back, one in the front. And the navigation lights on this airplane are red on the port side and green on the starboard side, and that is for every airplane, not just this airplane. So that's very important to remember when spotting other airplanes in the sky while flying. From this picture, you can also see the static port. I mean, you can't really see it, but it's there. And I'll talk about that more in depth later in this presentation. And you can see the transponder antenna, which is hooked up to the transponder, and I'll talk about that next slide. This picture also displays the marker beacon. And what the marker beacon does is it helps a pilot determine their position along a route. So let's move into the cockpit. I know this looks like a lot, but it's not. And I'm just going to break it down for you. So the 6 main instruments you need to fly are the airspeed indicator, the attitude indicator, the altimeter, the turn coordinator, the heading indicator, and the vertical speed indicator. And those are what are often referred to as the 6-pack inside the cockpit. The airspeed indicator, altimeter, and vertical speed indicator work by what is called the pitot-static system, and I'm going to go more in depth in that later. And the turn coordinator, heading indicator, and attitude indicator work from what is called the gyroscopic system, and I'll go over that as well later. So let's go over the more basic parts of the cockpit, and that is the clock, tells you the time, the suction gauge, which is also part of the vacuum system. This lets you know how your vacuum system is working. So it needs to be in the green. If it's not, most likely your turn coordinator, attitude indicator, and heading indicator are going to be incorrect. Then we have the 2 fuel gauges. This tells you how much fuel is in each tank. We have the oil, temperature, and pressure indicators, which tell you how your engine is running. If your oil pressure is low, there might be a leak or not enough oil in the tank. If it's high, there might be too much oil. Then we have the tachometer, which tells you the revolutions per minute and shows you how much power the engine is producing. We have the ammeter, which measures the voltage your airplane is producing. Then we have the rudder pedal, which controls the rudder on the tail of the plane. We have the elevator trim, which controls the elevator also on the tail of the plane. We have the light switches, which controls the lights outside. The carburetor heat, also known as the carb heat, which prevents icing from forming on the pitot tube. The throttle, which controls the power of the aircraft, how much it produces. The mixture, which controls the amount of fuel added to the intake airflow. There's the yoke, the mic plugins for your headsets, the transponder, and the transponder is used for ATC to know where you are located at. Then right above the transponder, we have COM 1 and 2 and NAV 1 and 2. COM 1 and NAV 1 are located on the Garmin 430 in this airplane, and that's pretty standard now. I haven't seen a trainer airplane without a Garmin 430, so that's what you'll most likely see unless you're in an all-glass cockpit. Right above that, we have the audio panel, and this controls COM 1 and COM 2. You can switch back and forth or listen to them at the same time. This also controls the volume in your headset. And right next to that, we have VOR 1 and 2, and this is controlled by NAV 1 and NAV 2. The VOR helps determine a course or help a pilot stay on course. Now let's move to the outside of the airplane. As you can see from the left picture, COM 1 and COM 2 antennas are two separate antennas, and that controls COM 1 and 2 inside the cockpit. We have the emergency locator transmitter antenna, which is hooked up to the ELT inside the aircraft, and the ELT is inside the aircraft in case of an accident and will go off automatically when an airplane crashes to help search and rescue teams. Then we have the vertical and horizontal stabilizers, and this is a very important design feature of this airplane and really all airplanes. The vertical stabilizer helps control the side-to-side movement of the aircraft, and the horizontal stabilizer helps control the up and down movement of the aircraft. On top of the vertical stabilizer is the beacon, and the beacon blinks white flashes of light to help the aircraft be more visible at night to other aircrafts. And right behind the vertical stabilizer is the rudder, and this controls the left and right movement of the aircraft and is controlled by the rudder pedals inside the cockpit. Now in the picture to the right, we can see the VOR antennas, the white navigation light, the rudder again, it's a better picture of it, the elevator that controls the up and down pitching motion of the aircraft. Then we have the elevator trim tab, which helps relieve some of the pressure in the yoke for the pilot. Now let's move to the wing of the airplane. The wing is held together by a bunch of ribs and stringers that run across through the wing. The ribs are held together by what is called a spar, and the tip of the wing is called the wingtip. The aileron controls the lateral movement of the aircraft. Then there is the wing flap, and this creates more drag behind the aircraft and is often used for landings and short field takeoffs. Now let's move to the nose of the aircraft. We can see that there is a propeller which creates thrust. The spinner is placed over the propeller to make it more aerodynamic. Then we see the exhaust pipe which releases gases that could lead to carbon monoxide buildup, fire, or loss of engine performance. Now take a look at the engine air intake. The engine air intake is necessary for the engine to run. Without it, the engine would not receive air and therefore it could not create combustion. Then you can see the pitot tube on the port side of the wing, and I will be talking about that next slide and how it works. In the left picture you can see the pitot system, and the pitot system controls three vital flight instruments. The pitot tube is used to measure ram air pressure, and it powers only the airspeed indicator. The static port is a small hole on the outside of the aircraft that measures air pressure. So let's talk about the airspeed indicator. This works by ram air going into the diaphragm, and when the diaphragm expands, this moves linkages, which in turn moves the pointer to the right airspeed on the front of the instrument. The reason that the airspeed indicator is hooked up to the static port is because without it, the airspeed indicator would show different airspeeds at different altitudes. Next, let's move on to the altimeter. The altimeter works by wafers that expand and contract based on the pressure outside. When the wafer expands, this causes the linkages to move the hands on the front of the instrument clockwise and show an increase in altitude. When the wafer contracts, it's just the opposite. It shows a decrease in altitude, moving the hands on the instrument counterclockwise. Now let's move to the vertical speed indicator. The vertical speed indicator displays your climb and descent rate in feet per minute. It does this by creating a difference in pressure inside the diaphragm and the case. It is done by having a calibrated leak. This leak controls the amount of air pressure allowed inside the case, but the diaphragm has the same air pressure as the outside air pressure is, which results in two different pressures. The difference in pressure allows the instrument to display the vertical speed. Now let's move on to the gyroscopic instruments. This includes the attitude indicator, heading indicator, and turn coordinator. The attitude and heading indicator are powered by air, and the turn coordinator is powered by electric. Now let me explain how the attitude indicator works. It shows the pitch of the airplane and the roll of the airplane. It does this by having a gyro inside that keeps the horizon level. Now let's talk about the heading indicator. The heading indicator shows a pilot what direction they are flying and needs to be adjusted every flight for proper readings. The way this works is the gyro and main drive gears stay upright and spin the compass card gear, which in turn spins the card on the front of the instrument. Now let's talk about the final instrument, and that is the turn coordinator. The turn coordinator is powered by electric. The gyro has a motor inside it, which rotates it. The gimbal is what holds the gyro upright, and the canted gyro is what turns the miniature airplane on the turn coordinator. It does this through a series of linkages. The turn coordinator also has an inclinometer, which measures the side-to-side movement of the aircraft's nose, which is also known as the yaw. Now let's move on to the control system of the aircraft. The control system includes the aileron, elevator, rudder, and elevator trim. This system is designed with a series of cables that run throughout the aircraft. The aileron control system operates from cables that run from the yoke to the aileron. The aileron can move up or down because of a bell crank, which pushes the aileron up or down. The elevator control system is also controlled by the yoke. When the yoke is pushed in forward, it causes the cables to have slack and therefore pushing the elevator down. When the yoke is pulled, it pulls on the cables, therefore pulling the elevator up. The rudder control system works in a similar way. When you push on the rudder pedal, it pulls the cable on the side you're pushing on and causes the rudder on the tail of the plane to be pulled in that direction. The elevator trim control system is a very simple design. When you turn the trim wheel up, this pulls the cables, which pulls the elevator trim tab up. And if you push the elevator trim wheel down, it loosens the cables and allows the elevator trim tab to go down. Well, that's the end of my presentation. I hope you enjoyed it and learned something from it. Have a great rest of your day.